I've started, but I need to wait for the lag to just sort of stop happening. Take the opportunity to clean my glasses, so you're not seeing reflected stuff and all the smudges. There's still a little bit of reflection. That's okay. Good morning. Is it happening? There we go. Excellent. Welcome. I'm going to take this out now because it sounds good, and if I don't, you'll hear a little bit of an echo. Good morning, campers. It is the last day of Intro to SQL. I hope that you have been having fun. This is, I think I mentioned yesterday, this is the join lesson. So if you want to get the notebooks for all of these, they are all on Learn, so kaggle.com/learn/overview in the Learn heading. Yeah, most of you should say Learn here. And then it's the Intro to SQL course, and we have been working through, and now we are on joining data. So we've done a lot. We've talked about what SQL is, what BigQuery is. So BigQuery is the SQL service we're connecting to on Kaggle. We went over a lot of the verbs, the clauses, I think they're called in SQL. SQL's an interesting programming language because the things that things are called are pretty different from what they are in things like Python or C or Java or R or whatever language you're using. Good morning. Chandon says, do we have to commit our exercises to get a certificate? I would recommend committing your work. I might be able to get the information I need if you don't commit, but it's a surer thing if you have committed. So, gotta stay hydrated. And I'm going to try not to look at the chat again, because I know if I start looking at the YouTube chat, I'm going to go off on a tangent, and it'll be really rough watching this video back later, so I'm going to do my best. So we talked about SQL, BigQuery, what it is, and just a refresher, because this was a while ago at this point. SQL is basically a way of interacting with databases on the assumption that every table in your database is sort of like an Excel spreadsheet. So it's tabular data like you would work with in a spreadsheet program, and we are manipulating it using this language rather than through visual interfaces. And actually, a little bit of a tangent. If you are in, this isn't actually a useful thing to look up. If you're in some spreadsheet programs, well, whatever. I was going to show you that in Google Sheets, you can actually write SQL queries in Google Sheets, but I think it's going to take too long for me to get to an appropriate spreadsheet. So whatever, no big. And it can be private, and I said I wasn't going to look, but then I looked. But yes, it should be able to be private. So some of the verbs we've learned: select, that tells you what columns you want from the name of the table that you need; where, which lets you filter based on the qualities of the rows; group by, a way to sort of consolidate down in groups; having, to sort the groups once you've done that; and count, to aggregate, so you could use count and look at the number, you could use sum and look at the sum, mean. I think there isn't a median by default in SQL. Order by, to sort the results you get back, and then as and with, which are how you do sort of variable assignment in SQL. So as, you can rename specific columns, and with you can create something called a common table expression, which is a little table that you can refer to in the rest of your query that has the subset of data that you're interested in. So super duper fast review. We're going to talk about joining data. So that is this notebook. Wow, sorry, good morning. The antihistamines are working. I can breathe through my nose again, which is really nice, but I am a little foggy. Oh, somebody's dog. So, joins. So far, everything that we've written, we've been looking at, very barky dog, the data in a single table. So way back on the first day when we talked about relational databases, which is what SQL is, I mentioned that you will have different tables and they will have relationships to each other, usually by some sort of key. And we're not going to talk about keys too much, but the general idea is that for every table in your database, you should have one unique way to identify every row in that table. And you can use that unique way of identification and refer to it in other tables. And this allows you to take data from table A, data from table B, and squanch them together and ask questions about both of them. So an example of what this might look like, if you are running an e-commerce site and you have, let's say, a list of all of your products. Each product will probably have some sort of ID, probably like a SKU if you're working in retail, at least in the US, which I think is SKU. I don't know what it stands for, but that's what it's called. And then you might have a list of customers in a different table. So these are people who have an account on your e-commerce site. And then you might have yet another list of orders. And you might want to know that in an order, this is a very complicated imaginary database schema I've come up with. So you might want to know how many orders were made by a specific person, and then the number of unique items they asked for in each order. And then we might, with the information in our database of different products we might want to be like, does this person tend to buy a lot of home goods? Do they tend to buy a lot of food? So maybe you're helping somebody out with a problem, or maybe it's you're a wholesaler and you sell to different companies, and maybe you notice that one of the companies that you work with is buying a lot of potatoes, and you're like, oh, usually they buy home goods, so you might see if maybe you want to recategorize them in your database to be like, this is a restaurant instead of this is a store that sells home goods, I guess. So you can ask much more complicated questions once you start having access to multiple tables with data in them at the same time from the same database. And that's what joining does. So we have a little bit more concrete of an example here. And let's open in a new tab so we can actually see this good. There we go. So here we have two data sets. So this one is the one that we've seen before. So this is the name of all of the different animals in our vets data set. And this is the type of animal that it is. And you will notice that here we have an ID column, and that each row has an individual ID. So this would be the primary key for this table. And you don't need to know the key terminology. I'm just mentioning it because you might hear somebody talking about it in the future. And then we have another table, and here we have the names of people who own different pets. And we have, each owner has its unique ID in this table, but we also have a pet ID here. And the pet ID refers to a row in the pet table. And it doesn't have to be called pet_ID, it could be called anything. But the idea is that this column is a reference to a different table, this column. So if we look through here, we can see that Jules Spinner owns pet ID number 4, which is Tom, which is a cat. Or Magnus Burnside owns pet ID number 2, which is a dog, which is called Moon. So that's the general idea of how these two tables are related to each other. So we can do a lot of things already with the SQL that we know so far. But we haven't yet talked about how to do these relationships with code. So here's just a visual representation of the things that I was saying earlier, that this pet ID key is referring to this key in this table. And you will notice that they are not in the same order. The order is different. So how do we join? Let's open this image in a new tab. No, it's big. Sorry. There we go. Now it's a good size again. Maybe my nose isn't totally clear. Excuse me. So we want to join these two tables together. So here, these are the two tables that we're looking at. We have this one that has the owners, this one that has the pets, and we want to create a new table that has the owner name and the pet name next to each other. Maybe we have some questions. Maybe we run a vet clinic and we want to write an email, and we want to make sure that in the email we're like, hey, owner name, it's time for you to bring in your pet name for their annual checkup. And so we want to get these pieces of information together so that we can send out an email to the people for our vet practice that need to come in and get their rabbits and dogs and cats seen to. And this is what the code would look like for that. So we are using a lot of things that we've seen previously. So we are selecting some different things here. So we are selecting p.name as pet_name. And this P here actually comes from one of the data sets. So p.name here means that I'm looking at the data set that I have aliased as P, and then I'm getting the name column from that data set. So this P is coming from the BigQuery public data. So this is the project. Pet records, that's the data set. Pets, that's the table as P. So I am aliasing it down here. I'm giving it a name, and the name is P, and then I'm using that name, and I'm referring to the name of a specific column. And if we look at the pets table, here, you can see that name is a column in that table. So I'm selecting that. And then I'm also doing this thing where I have an O. So O as owner name. And I'm doing here, you can see something called inner join. So there's a lot of different types of joins. We are talking about inner join, which means that we will only get items that occur both in the two data sets that we're trying to join together. So if you remember like logical and logical or, the inner join is logical or, which means you'll get it if it occurs in both of them, but not in just one of them. There's also something called outer join, which would be logical and, which would be get everything from both tables. I would warn you to be very careful with outer join, especially with BigQuery, because these data sets are big. And if you're trying to join two very large tables, you get a truly enormous table out. And that's a really good way to blow through your quota. But we're going to do our queries with a little safe config safety belt. So you don't have to worry too much about that. But if it doesn't work and you can't figure out why, that might be part of the reason. So we're doing an inner join, which means we're only looking for rows that are in both of them. So if we had, let's say we had another row in this owner table and it said, I don't know, Griffin McElroy, and he doesn't have a pet, then when we do our inner join, that row wouldn't show up in our new data set because it doesn't exist in both of the data sets, if that makes sense. So you can see there's only 4 pet IDs. So if I had like a name here and then pet ID 5, there is no pet ID 5 in this table. So I'm not going to get any results back from that. And vice versa, if I had, let's say, pet ID 5, Benjamin, who is a gerbil, but it doesn't have an owner and there's no owner that has the pet ID 5, I won't get that back either. So I'm only getting rows back that occur in both the data sets, if that makes sense. So that's what the inner join means. And we are actually looking at a separate table here. So you'll notice that the project is the same, the data set is the same, but the table is different here. So here we have pets and here we have owners. We're aliasing pets as P, which we're referring to up here. And here we're aliasing owners as O. And you can see O.name if we look back at this table. Okay, yes, owners does have a name column in it. So we're getting information out of that name column. And we're giving these names, see, both of these columns are called name, and we're giving them different names that are, or aliases. They're a little bit easier to remember. So pet name, oh, that's the name from the pets column, from the pets table. Owner name, okay, that's the name from the owner table. So this is a little bit easier to read than if you didn't use the as and then give it a new name. And you will also notice, in addition to the inner join, we have this little thing here that says on. And this tells us which columns to look for to allow us to link the two data sets. So here we have p.id and o.pet_id. So p.id is the ID from the pets table. So it's this unique value, this primary key. O.petID is this pet ID column, which refers to the ID column in the pets table. So these are linked in the design of the database, and this is sometimes called a foreign key. Again, you don't have to know that, just sometimes people will talk about it. So I'm saying, okay, I want you to look for all of the rows that have a pet ID that matches, a pet ID in the owner table that matches an ID in the pets table, if that makes sense. So we're using this to be like, okay, these are the rows that go together, and then only the ones that match will be returned in our final table. And then from that final table, we are selecting pet name and owner name. So we have this this sort of condensed version of our data. That's the general idea with an inner join. With an outer join, if we had columns that didn't exist in one or the other, we'd get all of them and they just have some, blank or null values for the information it couldn't fill in from the second column. And there's also other things like left join, right join. There's a bunch of different types of joins. I tend to use inner join most often. And it's also, I think, the safest because it can't be bigger than either of the data sets, and some of the other joins can be bigger than some of your input data sets. It's a little bit scary, especially when you're working with a big data set. So that's the general idea. Let's work through an example with code. So I'm going to, let's see, this is the GitHub repo data set. Let me copy this code here, and I'm just going to create a new kernel. And again, we don't expect you to do this every time. Oh, excuse me. Maybe the antihistamines aren't working that good. Sorry about that. Actually, rather than starting a new kernel from kernels, I'm going to start a new kernel from the data set. And it's a GitHub data set, and it's a BigQuery data set. There we go. So this is the one that it is written on, and I'm going to create a kernel on this. And what this just does is it creates my kernel with the data set already added, so it doesn't have to restart when I add the data set the second time. That's all that's doing. Column type unknown is not valid. That's exciting. GitHub, what was this? Join scratch patch. Join scratch pad. There we go. Copy this code we got in here earlier, and this is based on the things that we talk about in the all of this client stuff code is from the first day. Woo, that took a long time to pull out of the oatmeal. And somebody pointed out that you can actually work around needing to use this particular line. I think we talked about that in the video yesterday. So if you wanted to make your code a little bit tighter, you could, but that's just the way that we're doing it. All right, so this is all the setup. This is getting our references to our data set so the client can go and fetch all of the data that we need. And now let's actually do, and this is a second table that we have. So we have, actually, let's slow down and look at these tables a little bit more closely. So this table has the repo name and then the license of that repo. So on GitHub, repo or repository is sort of a collection of code. And a license is, the permissions that you need to be able to use a piece of code and what you can do with it and all of that sort of stuff. And then we also have this, what's it called? Table, which is a little bit bigger. And it has a reference to the repo name. It has a ref, and I don't know what that is, but we could look it up in the documentation if we were curious. It has a path, so it looks like this is a path to a specific file. So it looks like each file is going to have its own row in the table. Mode, don't know what that is. ID, that looks like to be a unique ID for each row, I guess. Symlink target. Looks like a sort of a shortened version, or maybe from the ref that is the path to the specific file that you're looking at, potentially. So there's a little bit more information in here. And we want to look at the number of files per license. So the information that we have is we have the license that each repo has, but we don't have the license that each file has. So this column here, license, doesn't exist in this table that tells us about each of the individual files. So we need to do a join in order to get the information about how many files we have covered by each license. And I don't know why you'd want to ask that particular question, but we do. Oh, sorry. All right, so let's run this query, and let's go over it first and then run it. So we're doing a couple of things here. So we are selecting L.license. So this is going to be from the table that we're defining L here. And this table is BigQuery public data. So that's the repo. That's the project. GitHub repos is the data set, and then licenses is the table, and we're calling this table L. And if you remember, this table has the column license in it. So that's the information that we wanted. And then we are also doing the number of files. So we're taking the count of the number of rows. And this is going to be, because we're not saying that it's from this L data set, it's going to be from the one that we are doing. It's going to be from the one that we're doing this from. Yeah, sorry, I had a bad moment where I was like, is it actually just going to be the number of rows in the final joined data set? I think it might actually be. I think that this might actually be based on the number of rows after the inner join rather than... No, that can't be, because then it would need to be a left join. Anyway, I've gone down a weird rabbit hole here. But basically, we're counting the number of rows as number of files, so we're giving this the name number of files. And then we are also getting that information from the BigQuery public data GitHub repo sample files as SF. Yeah, I'm wondering if we can do something like sf.count1. I don't know. That's something we can play around with for a bit. And then we're doing an inner join. So we've created, I mentioned it before, we created this alias L for the licenses. And then what we are joining on is repo name in the sample files and repo name in the licenses. So if I look in here, I can see that repo name has this sort of author and then repo or repository structure. And then if I look down here for repo name again, I can see that we have the same sort of author repository structure. Excuse me. Ugh. I can see that I have that same structure, and I don't see the same qualities in the rows here because they're not always going to be in the same order due to the way that it's optimized. But it should still work. So if we have a repo with a license and also we have files from that repo, we should be able to join over them. And then we are doing a little bit of extra stuff. So we are grouping by L.license. So we can see that one of the licenses that we have is this Artistic 2.0, but we're probably going to have some like MIT licenses, some Creative Commons licenses, maybe like GPL or different software licenses. So we're going to group by those, and then we're going to order by the number of files descending. So we're going to see the one with the most licenses first, and then going down until it has the fewest, the license that has the fewest files associated with it will be last. That's the idea. And let's run it. except I can't hit buttons good for some reason. All right. Oh, I see. And so we have run the query, and we've got the job as a data frame. We've gotten the results that are returned as a data frame. And I'm going to just print out the head of that data frame so we can see it. Of course, it does help if you spell head correctly. So you can see that the MIT license has the most files associated with it. So something like 20 million. GPL has something like 17 million. Apache 2.0, which is what Kaggle kernels are licensed under. If you make your kernel public, it's licensed under 2.0. Apache 2.0 has about 7 million. GPL 3.0, which is different from 2.0, has about 5-ish million, and so on and so forth. So these are the number of files associated with each different license. And then, yeah, so we're just looking at that same information in the notebook. I am a little bit worried that there might actually be a bug in this query. I don't think there is, but there might be. So I'm just going to quickly try something a little bit different. So for count number of files, instead of counting 1, because I don't know when that's evaluated, I am going to count ID from the SF. What was it? It was ID. Yep. I'm going to count ID from this sample files data set. I'm just second guessing myself here. This is taking quite a bit longer to run. All right, so this is the one that we had previously, and I'm going to create a new. This is not a good thing. So I'm going to create a new cell here where I'm running the same code, but I've overwritten the variable here with the new variable done this way, and it looks like the results are exactly the same. Okay, good. There is no, it looks like there's no difference in output between the two of these, but the runtime on looking at count of 1 was much lower. Interesting. I think there's something about optimization that I don't know about that makes the difference here. But there wasn't a bug in my query, which is really nice. Especially with joins, it's pretty easy to do bugs in your queries, and it's a little bit hard to figure them out if you get data that's in the state and configuration that you expect, but that the content is slightly different. And if you don't have a ground truth, which it's hard to get because the ground truth you would get by writing a query, it can be a little bit tricky to work around. Excuse me. And on Kaggle, we actually have a little peer code review for SQL queries. So if you're working on a SQL query and you're like, I think it's gonna work, you can reach out to other people who have agreed to be peer reviewers and get your queries peer reviewed, which is super helpful. And if you're in a data science group with a bunch of other folks, or I guess any sort of working environment with other folks who also know SQL, I think peer review is very helpful. Okay, so we are half an hour in, which means it is time for questions. And I'm going to start on the forums, and then I will pop on down to the chat. So discussion, learn, here we go. Question on the final exercise. Question on the final exercise wants us to use the like clause along with the where clause that expects a pattern to match. Here's the syntax as was demonstrated. My question is, since the query is already enclosed in a string, why do we use quotes in the argument to like? That is an excellent question. Oh, and Abhishek's already on it. But yeah, it's because, so this is a string when we pass it. So it's being handled as a string in Python, right? And then we are sending it through the client to BigQuery. And then BigQuery is treating all of this within the string as a single SQL query. So it's going to try to parse everything. when we are looking for something that's like something else, we're looking for a string to match against. So Python thinks this whole thing is a string, but once it gets sent to BigQuery, SQL does not think this whole thing is a string. It thinks this whole thing is code. So we need to say that this is a string for the SQL side, not for the Python side, if that makes sense. It's a little bit like I don't know, a game of telephone where you like whisper something to somebody and then they whisper it to somebody else, or like, I don't know, you guys ever play Pass the Parcel when you were kids, which is like, you have like a bunch of like small pieces of candy or toys, and then you wrap them up in a bunch of like cheap paper and you make this big ball, and then like you pass it around and somebody opens it and they get like the candy that's in it, and then they pass it around, the next person opens it. It's sort of like that. That's my very good metaphor. Let's see. Learn joins. Oh, a visual explanation of SQL joins. So this looks like it's not going to render super good as zoomed in as I am, but you guys could check that out. So it's probably going to talk about inner, outer, left, right, all of the exciting types of joins that we're not talking about with. Question about with as. Bad request order. Okay. Bad request order if equality terms for join condition is entertained. I get a bad request, query limit exceeded bytes build error if I order the alter of the equality condition in questions 4 of the exercise joining data. So you get a SQL error if they do parent ID equals ID instead of ID equals parent ID. The rest of my query is the same as that mentioned in the solution. So this... Let's see. Let's zoom in on the answer here. So it looks like that ran, but the this one didn't. And unfortunately I can't see all of the error message here, which would have been a little bit more helpful for me. One thing that could have caused this is the number of comparisons between the two. So if we have, we're getting into the part of the SQL that always gives me a headache. So when you're doing joins and the field that you're joining on, order doesn't matter for the output file, but it does for runtime because it can change the number of comparisons. Because if I'm looking in table 1 and let's say it has 4 IDs, and then table 2 and it has 200 IDs. If I go through table 1 and I look for each of those IDs in the second table, it's going to take me like 4n. But if I go through table 2 and look for each of those IDs in table 1, then it's going to be like 200n. But I don't know which one needs to go first, the smaller or the bigger one. And I'm thinking that the query bytes limit build error is because the safety net, the safe config we use. So, this one here says, hey, don't run this query if it's going to take more than 10 gigabytes worth of my total query quota. Because if you're working in a here you're not being billed for anything, but if you were working in a company that was using a product they were paying for, you would get billed for the amount of queries that you run and the amount of data that you scan. Yeah. And the other thing that you might need to worry about is, depending on where you're working and how your infrastructure is set up, the queries that you are running might be made to the same database that the people who are trying to use your product are using. So in the e-commerce site, maybe you're trying to you're trying to analyze, what products are hot right now, but you're using sort of the same limited compute resource as the people who are trying to buy those products. So you want to, tread lightly as possible, which is why it's a good idea to optimize your queries. Yeah, so that's my guess about why that's happening. That seems reasonable to me. But again, I'm not super up on all of the guts of SQL because I care about SQL because the data I want is in SQL, and sort of like as an object of itself, it's fine. It's a good tool, but that doesn't mean I want to go to a hammer camp and learn a lot about hammers. All right, let's go to YouTube. Dragonfly says, what data do we use for those just joining the course? Do we use any data or the data set you use for each session? So if you're for your own learning, you are welcome to use any data set you like, of course. In the course itself, so learn, blah, 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 blah. Nope. Intro to SQL, not intro to machine learning. There we go. The exercises will already have data sets associated with them. So if I click the exercise here, it will fork an existing notebook, and I will get, you can see here, this is Stack Overflow data. I have a data set already attached and ready to go. And then once this launches, you'll see all the text for the different, what are they called? Exercises that you need to complete. So the idea is that you do the exercises and you don't actually need to go through the code in the example notebook like I did. Godfrey says, oh, so BigQuery is executed in Python. So it can be executed in Python. We're using the BigQuery client, which is actually an API basically, and we are using it from within Python, but there's other options as well. I think you can do like Java. I don't know. It's a bunch of languages I don't use. Maybe there's a Perl one? Hey, okay, yeah, I was right. Java's one of them. Looks like C#, Go, Java, Node.js, PHP, Python, and Ruby. So, all right. Mockingbird says, the data set was updated, the queries are bigger now. I would recommend 25 gigabytes as a limit. Yeah, these the BigQuery data sets we have on Kaggle are being continuously updated, so yeah, they do change size. Yeah, so there's some interesting questions about the order of operations here and how we can refer to data sets before we actually select them. So here we are selecting at the top, but in our selection, we are referring to this L data set that we only talk about down here when we talk about the inner join. I don't know that much about the abstract syntax tree of syntax of SQL and the way that different queries are executed. The reason that we have the clauses in this order is that there is a canonical order for the clauses. There is a single order that you're supposed to put all your SQL clauses in. Let's say SQL clause order. And they go in that order. This is about order by. That's not actually the question I had at all. Order of execution of a query, order of execution. Yeah, so this is just like the way you're supposed to, so this is not the way that you order them. This is the order in which they're executed. If you wrote your queries like this, people would think you were not very used to SQL probably. So it looks like the from clause is executed first. So if we look, down here, we have from, where we're defining what SF is defined after in the order the clause where we're getting the count information from it, but it still ran fine. Then where is executed. We don't have where in this query. Group by here, l.license. Inner joins must be executed right after from, I would guess. Let's find out. SQL execution order joins. Order of execution. Where is join in processing order? So this is the person's, here we go. Okay, so join comes third in the execution order. So it's from, on, join, and so on is what comes after here. But we're still referring to this thing that we've aliased here on. So if this is correct, then on should be, this shouldn't work because this is happening after we define this. Interesting. Yeah, Isabel says, so that goes back to my form question. The from executes, grabs the column with the variable, then locally does the extract as question mark, the order of operations table. Yeah. Data science says, boost the level. This is entry. It's intro to SQL. Advanced SQL is going to be later. If it's intro. Yeah. Ronnie says, but the from line selects the data set and is written after the select line. I think the big takeaway from here is that the order that you write your query is not the order that it's executed in, but there is a standard order to write the query in. Interesting. Yeah, looking for more questions. Isabel's again confused about the use of L before we define it in the query. Yeah. Godfrey, can someone explain what's a big query? Oh, that's a really good question. So BigQuery, I'm going to interpret this in two ways. So BigQuery is the service that we're using to run that hosts the SQL database and that we're using to ask questions through. A big query, though, is a query that needs to scan a lot of data to get the answer, not necessarily that returns a big table, right? So in my example where like one of the ways you have to make a lot of comparisons, the other ways you have to make fewer comparisons. And again, I don't know which way is the good way. And for all I know, BigQuery just like picks the most reasonable way off the bat. If you have to look at a lot of data and do a lot of transformations in your database, even if the amount of data that you're getting back is very small, then it would be considered a bigger query because it takes more time and it does more like futzing around. So an example for something that might take a really long time is, I'm trying to come up with a good example of something that's not super easy. If I were working with a database of like social media posts and I wanted to get all of the posts from people who had at some point posted from Madison, Wisconsin, right? That would probably take a fairly long time because I would need to, for each person, go through and check if they'd ever posted from Madison, Wisconsin. Or I even only got the most recent post for everyone who had ever posted about Madison, Wisconsin. So I need to look at all of their posts and see if they've ever been to Madison, Wisconsin, but then I don't return all of those posts. I just return the most recent one. So I have to look at a lot of data, even though I only give back a small amount, if that makes sense. So that's how I'm choosing to answer that question about BigQuery. Dragonfly, so how's BigQuery different for Snowflake or Redshift? I'm not super familiar with Snowflake or Redshift. It is relational, so it's not for like JSON type structured data. It's fast and it works with big data. It's a Google product, and Kaggle is also owned by Google, and it's very fast. And there are lots of other good database services if you prefer. And the SQL syntax should be pretty much the same. The query client that you are going to need to interact with is probably going to be different between different databases. So if somebody else has more information for Dragonfly, please feel free to hop in the chat. Shapangi says, what happens when the key is not unique in one of the tables of the two while doing inner join? you will get both of them. So in an example where, like, that's a really good question, by the way. So if Aubrey Little had two pets, one was Dr. Harris Bonkers, who's a rabbit, and the other was Gerald, who is a hamster, we would have, well, that's going to have to be, so we might have 2 rows in here. I'm trying to figure out how that would be represented in this database, and I don't actually know. This may not actually handle multiple pets very well. But if we had somebody who had multiple pets, I would expect to get a data set back from my query where I had, Aubrey Little, Dr. Harris Bonkers, Aubrey Little, Gerald, Chet Crawfish, Ripley, Jewel Spinner, Tom, Magnus Burnside, Moon. So I would expect to get the corresponding information multiple times if there was a repetition in keys, is what I would expect to happen. Good question. Abhishek said, records multiply. It gets messy. It does get messy. That can be a good way to do a very big query. Anthony says, if I work with BigQuery locally, should I attach the data set like we did in the exercise? No, that's just on Kaggle's side so we can handle credentialing and OAuth and all of that. You do need to set up the your authentication, but no, you do not need to you don't need to attach the data set. And actually somebody somebody posted some sample notebooks on I don't think this is the one, but somebody posted some sample notebooks on the forums where they went through and set up all of the exercises so that you could do them locally if you wanted. And I can't find them right now, but they are on the Learn forum. So that's a good place to start if you're looking to work locally. Yeah, and people talking about, you get the multiples and repetitions. Richard says, can a key field not be unique? I believe generally primary keys have to be unique, but foreign keys don't have to be. Pretty sure. That might be one of those things that's different between different flavors of SQL, but that's what I was taught when I was learning about databases as a wee data scientist. Helpful. Any good book for SQL from beginner to advanced concepts? I don't know of any off the top of my head. If you guys have recommendations, please let Raul know. Mostly I learned SQL by just like screaming a lot. No, I didn't do screaming. By just guessing and testing a lot and like looking things up on Stack Overflow, and I got stuck, which I think is the way a lot of people learn things. I know I've got like weird holes in my SQL knowledge, but I know enough to get by and get the information I need, so... and Abhishek is recommending SQL Zoo, so that might be a good resource for you guys to check out. All right, let's head back to the forums / I think it's discussion, Learn. All right, let's see. Google BigQuery advantages. Why BigQuery from this camp? Why not AWS or MS Azure, for example? Both work just as great with Jupyter notebooks. What are your main advantages, by your opinion, comparing Google BigQuery with AWS and Azure? From a practical standpoint on our end, we use GCP. The Kaggle runs on GCP, which is Google's cloud platform, which is what BigQuery is on. So from an infrastructure point of view from our end, much simpler. I think the biggest advantage of BigQuery in particular is that it is very optimized. So you're going to have to, I don't have like a bunch of stats at my fingertips, but I believe it tends to run queries faster and can handle larger data sets with better performance than similar services. I've previously used Azure Dataset Services, and it's like perfectly fine though. So my main recommendation, if you are trying to pick a service for database hosting, is if you're a data scientist, maybe try to make somebody else do that. I personally have really liked BigQuery, working with it. Other database services are personally fine. If your company is already using one, sort of like cloud ecosystem, don't be like, hey, we're using Azure, but I really want to use AWS instead, because that's going to make billing just a nightmare. I would recommend sticking with sort of like the one that you've picked. And if you are, you have not leisure, not levity, not leniency, if you can just pick for yourself, try them out and see which one you like. And people who know more about database services could probably give you a better answer than that. Question about join, and I can't click. Can we alias the data table returned after performing the join operation? If yes, how? Is it possible to join more than 2 tables? Yes, and I think yes, but you need to make an intermediary table. So Abhishek has an example. So I'm pretty sure you can join more than 2 tables, but you need to start by joining 2 and then take those 2 that you've joined and join the third, et cetera, et cetera. I think you can only join 2 at a time. Or at least that's the only way I've ever seen it done. If you can join like 3 tables at the same time, I'd like to know how to do. No, I don't think I'd like to do that. I think that could get very confusing very quickly. It would be cool if you could. Akash says, how can we practice more on BigQuery along with code and output? Well, we're going to continue. So this event is part of SQL Summer Camp. So this is the intro course. On August 2nd, we're going to do BigQuery ML, which is machine learning in BigQuery, which I'm really looking forward to. And then we're going to have an advanced SQL course, and all of those are going to be in BigQuery, but also the advanced SQL course is just like things that are very transferable to other flavors of SQL as well. Mockingbird says, is there any update on the names on the certificate? My suggestion would be a program that runs a SQL query for your exercises and lets you fill out your own name on a form. Yeah. Sorry, I'm thinking about the logistics of that. So we're probably going to email people PDFs. I'll see about names. Nick says, I don't remember the order of operations point coming up during the tutorials. It strikes me as an important point. I mean, yes, but I don't think you need to know about it to still write good queries. Yeah, I did want to find information on, there is like a canonical order that you write SQL queries in. SQL query order to write queries. It's not a good... Okay, so this is order of execution. Order of execution. How to write better queries. Well, that's from Data Camp. Subqueries. Back to basics. Our data. Select. Order by. Junction table. Oh. I've never heard of a junction table. Oh, it's SQLite. Okay, that makes sense. This is very different. Oh, I can't find it. Anyway, there is a specific order that people expect you to write your queries in, and it's select from where, group by, order by, actually select from where, join on, order by, group by. No, group by, order by. Order by comes last. Yeah. Yeah, I think it'll run if it's out of order. It just, there's a canonical order. All right. Pavel says, BigQuery has many public data sets in its cloud. Oh yeah, that's true. There is a lot of public data available on BigQuery that you can mess around with and play with and learn cool things. Dragonfly, how long does it normally take a notebook to start? It depends. It's starting a virtual machine, so you can think of it like booting up a computer. It shouldn't take that long unless you have, I think, 4 notebooks currently running. So if I look at kernels, you can see that I have 2 notebooks running right now. If I tried to open 3 more, the third one wouldn't start, and so I'd have to stop some of these notebooks in order to, actually I'm going to stop this one and also close that, in order to free up compute so that I could continue working. And some suggestions for W3 schools. Jakit says, junction table that has keys from table 1 and table 2. Again, I have never heard of junction tables before, so that's something for me to research in my own personal time. All right, let's head back to the forums. com/discussion/forums. Nope. Learn. Did I type it bad? I think I did. Oh, it's kaggle.com/learn-forum. All right, let's see. I think we talked about these. We talked about the ordering. Reverse the on part breaks code. So I think this is the same question that, oops, I didn't mean to do it in a new tab. Yeah, I think this is the same question that Deborah Praya had. The order of tables doesn't matter for inner joins. It does matter for other types of joins, though. That is true. It works as fine as long as the tables are on the correct side of the join clause. So you wouldn't want to talk about these before the inner join and from, but we can still refer to it in select. Oh, wait. Okay, this does actually make sense to me. So we're looking at this table, then we're joining it on this table using these keys. Once we've done that, we're selecting the columns that we need. And then we're grouping by license. And then we're ordering by number of files. I still don't know. Okay, so let's see. So the licenses by repo name didn't work. And having the licenses second and the files first did work. And I think this is not working because it's bigger, not because the code is wrong. Because you should be able to switch them syntactically, but I think the size of the query is different. Interesting. So if I remember correctly, sample files is the largest one. Or maybe it's that one of them is the one that you're selecting from and one of them is the inner join. I don't know the answer. There's a lot of reasons that it could be, and I just don't know. Mustafa says, isn't deep learning all about neural networks? How would that happen with SQL? Deep learning is mostly neural networks, yes, but there's a whole beautiful ecosystem of other types of machine learning that are much cheaper in terms of compute and generally work just as well as or better than deep learning. I gave a talk at PyCon this year about when not to use deep learning, and the answer is honestly most of the time, particularly if you are working as a professional data scientist, unless you are building products around deep learning specifically. So BQML has specific algorithms built into it that we will talk about. Should be fun. I'm really looking forward to it. And yeah, SQL is a data query language. It is not. I guess you could do deep learning in SQL. I mean, you can do a lot of things with SQL. It's Turing complete. Should you? Probably not. Like, I wouldn't recommend it again. But Actually, I bet somebody has. I would bet good money that someone has already done this. Yep. Yes, I knew it. I knew someone would have done it. And over BigQuery, actually. So if you wanted to, you could, but we're not going to. All right, so it is about time to run out. Oh, Peter saw the talk. Thank you. I'll put this link in the forums for you guys to enjoy and read at your leisure. I am going to call it here. I'll be on the forums today. I'll see you guys on Kaggle, and we will announce the t-shirt winners for this week soon. And if you want to be in the running, just ask some questions or answer some questions on the Learn forums, which is we just discovered at kaggle.com/learn-forum. And I will see you on Kaggle. And then the next event in the series is going to be on August 7th when we're going to talk about BQML and do some machine learning in BigQuery, which I am honestly more excited about. SQL is very useful, but also I think can be like a little bit dry. So I will see you on the site and also on here on August 7th for the next SQL BigQuery thing. And tomorrow for live coding, we're working on a project to do some natural language processing to summarize information from the Kaggle forums. And last week we trained word embeddings, and Ryan Chesler, who's a Kaggler, trained better word embeddings, so I'm probably gonna use his code to keep working on that project, do some summarization, do some classification. All right. Thanks so much for joining me, everybody. I hope this was informative. I've definitely got some new stuff for me to look into and learn more about. And I will see you on Kaggle. Bye.